And this leads us to the concept of tonicity. I think I've mentioned it before, hypertonic, hypotonic. What is tonicity? Tonicity is the tone of a solution, and the tone of a solution is uh, how much oncotic pressure, how much um, osmotic pressure it generates. And basically it tells you how much solute there is in one solution compared to the other. So for example, if we have two solutions in one container separated by our usual semi-permeable plasma membrane, and we have equal concentrations of a solute in the two compartments, it means that we have net osmotic pressure of 0. So the two solutions are isotonic. There's not exchange of water. Oh, I must say something important. In these models, the solute, so in this case, you know, the orange particles are not able to cross the plasma membrane, the semi-permeable membrane. And you know, the same occurs in biological membranes, because as we said, the main driving force for the osmotic pressure is in the extracellular fluid is sodium. And we do know that in resting conditions, plasma membranes are impermeable to sodium. But if we put higher concentrations of the solute in one compartment, for example, in the right compartment, then we will have, osmotic pressure pushing from left to right, movement of water from left to right. So from a hypotonic solution to the hypertonic solution. So water will always flow from the hypotonic solution, with the solution that has a lower amount of equivalent in it, to the solution with the higher amount of equivalent. So it always moves from hypo to hypo. So this is just super duper important, right? Because obviously if we place a red blood cell that has an intracellular solution, intracellular concentration of equivalents of around 280, 290 milliosmoles per liter, and we place the cell into a hypotonic solution, so in a solution that has less than 286 milliosmol per liter, for example, 200 milliosmol per liter, then water will move from the outside of the cell to the inside of the cell, and the cell can swell, and it can pop. It can actually explode at some point, right? While if we place it in an isotonic solution, 286 milliosmol per liter, then there will be no change in the volume of the cell. Well, if we put it in a hypertonic solution, right? So for example, if we inject some saline solution that is too concentrated, 360 milliosmol per liters, for example, the cells will shrink and the person will... In summary, body fluids are composed of water, which is the solvent, and dissolved substances, which are the solutes. There are three main compartments, which are the plasma, the interstitial fluid, and the intracellular fluid. Just to remind you for the 100th time that plasma and interstitial fluid constitute the internal environment. Water is a complicated molecule that has a number of properties, and these properties make it the primary substrate of living organisms. Always remember the fluid intake and output are always balanced with each other. Also, within each body fluid, the positive and negative charges are balanced, so each compartment is not electrically charged. The concentration of electrolytes in the intracellular fluid and the extracellular fluid is very, very different. However, the number of osmoles per liter in the two compartments is the same. They're isotonic. The movement through the cell membrane, by now you must have understood it, occurs by passive diffusion or passive or facilitated diffusion or active transport. And osmosis is basically the diffusion of water. while tonicity is a measure of osmolarity or osmolality in one component. And this leads us to the